Here we have definition number 1, the definition of an improper integral of type 1. Part A, if we have an integral of a lower limit of a to an upper limit of t of a function dx exists for every number where t is greater than or equal to a, then we have the following. We have an integral that goes from a to infinity of f of x dx, which is equal to the limit as t approaches infinity from a to t f of x dx, provided this limit exists as a finite number. Now for part B, if we have an integral that goes from t to b of f of x dx exists for every number where t is less than or equal to b, then we would have the following. The lower limit is negative infinity, the upper limit is b of f of x dx, which is equal to to the limit as t approaches negative infinity from t to b f of x dx, provided that this limit exists as a finite number. Now, the improper integrals for these two situations are called convergent if the corresponding limit exists, and divergent if the limit does not exist. Now in part C, if both of these integrals going from a to infinity and then from negative infinity to a are convergent, then we would define the following. So if we have a limit going from negative infinity to infinity of a function dx, then that would be equal to the lower limit of negative infinity to a, f of x dx, plus the lower limit of a going to positive infinity, f of x dx. Now in part C, any real number a can be used. Now any of the improper integrals in definition 1 can be interpreted as an area provided that f is a positive function. So for instance, in case A, if the function is greater than or equal to 0 and the integral going from a to infinity of that function is convergent, then we define the area of the region S equal to a point xy such that x is greater than or equal to a and the y value is in between 0 and f of x inclusive. And if you take a look at figure 3, we can see that the area of the function of s going from a to infinity of that function dx. So this is appropriate because this integral is the limit as t approaches infinity of the area under the graph of f from a to t. So as a is going to t, we can see that this is appropriate for that particular integral. Now if we come back up here again, just make sure that you pay attention to this part here. Okay, the value of infinity is now becomes a limit as t approaches infinity, and now we have this value of t. Same thing here for this lower limit, we have a negative infinity. As t approaches negative infinity, now we have this lower limit for t.